And need to just say that we're very lucky to have Kimberlee here for this presentation. I saw a preview of it at River Legacy some time ago, and it's got a lot of very good information in it. I've known Kimberlee for a couple of years now. I've used her to diagnose tree problems and things like that. She has a BS in wildlife sustainability, ecosystem sciences, and a master's in ag and natural resources. So she's well qualified to do everything that she's doing. She's going to talk about the symbiosis between trees and insects, and probably you never thought of most of the things she's going to talk about. And you probably want to capture her email address somewhere. So if you have problems with trees or anything related to insects and trees, you can get a hold of her. And she covers I think the east side of the DFW area. It's a huge area. And I don't know, Kimberlee, if you have someone working with you covering, you cover the west side, the other person carries the east side, so.
So I cover 31 counties in North Central Texas. So as a grand total of population, we're looking around 8.5, 8.6 million. So I do now have some help to help me cover my eastern part of my region. So Dallas and a little bit east of that. So my eastern border would be Kaufman, Hunt, and Fannin counties. But I go as far west as Abilene. Glen Rose is my southern border, and then the Red River is my northern border.
Yeah, so she's busy. Okay. Take us away, Kimberlee.
Awesome. Okay, so tonight we're going to be talking about the relationship between insects and trees. This is extremely broad, and it took me a while to figure out how did I want to make this presentation when River Legacy came to me and asked me to participate in their bug squad exhibit. And I was like, well, how can I do something like this justice? And I actually worked with our forest health coordinator to put this together and kind of talk through a few different things. And so you're going to notice that in this presentation, it is not black and white. The world around us, the natural resources around us, it's more complex. There's a lot of relationships that we don't see or possibly understand, and that's okay. We just have to be kind of open to seeing all the different arrows pointing in all sorts of directions. We all have seen like a food web before, at least, a very basic one. That is something that I wish that got more complex as you go through your education, because I feel like the same food web I saw in elementary school was the same one I saw in my master's program. And so you don't really get the full idea of how complex everything is. So I hope that you're able to get just like a brief little show of just what that's like. So I'm going to start off with two questions. We're going to see if this works this time. It didn't work at River Legacy. But I'm hoping that it's going to work this time. Oh, there we go. All right. So what do you think about the relationship between insects and trees? You can go to slido.com and enter in that code, or you can scan the QR code. And this should be interactive to where we can see people's response real time as y'all are putting it in there. So it's kind of an interactive presentation, and I hope that we have some really good conversation from it. Awesome. All right, we got some positive, we got some combination. No negative or unsure so far. Awesome. Okay, so I think that might have been everyone.
Does that mean you got
How many people
7
are,
people that have entered it?
yeah, there's 7. So are there 7 people on this call?
No, I think there's like 17, including you.
So you should have 16. I'll give y'all a little bit longer.
Still trying to get yours. I'm on Slido, but do I have to scan the QR code? But I do.
That's okay. This is the first time I did this. I was trying to use Microsoft Forms for the survey. And then I went back and was like, okay, well, that didn't work. So I'm trying Slido because it's like a free edition on PowerPoint. So we're going to see how that works. Because I like having an interactive presentation.
Yeah, Dick, I just tried it. If you scanned in the code there, it pulls it right up on your phone. Very straightforward.
It was really easy.
Cool.
I'm on my computer, so.
Well, if you got your phone, it's quicker.
Oh, yeah, I can do it that way.
Or just type in the number on your browser, 4163318.
Just go on, just go ahead.
Okay. So I am really glad that a lot of y'all actually selected combination. You know, it's very much it depends type of situation. It depends on, you know, what is that interaction. And we're going to kind of go more into depth as far as like different types of relationships and what those actually mean. The next thing is, what do you think of whenever you hear healthy forest? And this should just allow y'all to just type in it like a single word or a couple words. Nice, diversity. Lush, green, and active. Green and healthy bark. Cool. No humans. I can, you know, I would love that. New and old trees. Right. Alive, tall trees, understood. Nice smell. Forests do smell very nice.
I bet they meant understory rather than understood.
Oh, understory. Okay, cool. Good mix of age classes. Yeah. Yeah, I can agree with all of those. My thought whenever I think of, you know, like a healthy forest, I just think balance. We need to have some sort of balance going on. Because as soon as something gets disturbed or, you know, we have, like, for example, like crazy weather patterns that we have, where it stresses out the trees are no longer in balance because they've been stressed. And that allows for a lot of disease and pests to come in. And then if you only have one species of trees, that's allowing for, you know, one environmental event or one disease or pest to come in and wipe out the entire thing. So we need to have a balanced forest. We need to have a little bit of everything, in my opinion. All right, so what is a healthy, or what is forest health? So forest health, the definition for that is the overall condition of a forest, including its ability to withstand and recover from stress. And so kind of already touched on that a little bit. Okay, so if the forest isn't healthy and, you know, a winter storm comes through or the drought comes through, it can't, you know, recover as easily because of that. It's already weakened. And so if it's already stressed and then that, you know, storm comes through, it weakens it even more. It allows insect borers to come in, all sorts of things start getting very unbalanced. And then the definition for forest ecology is the study of interactions between all the biotic and abiotic components. So biotic means living, abiotic means non-living. And so whenever we look at an ecosystem or a landscape, we're looking at a few different things. One, yeah, you're going to look at species abundance, which is the example on the left. On there, you see 17 individual trees, right? Now, species richness, which is more what I like to look for whenever I'm out on properties. I see that there's 6 species, you know, of biotic living things. There are at least 2 tree species, and there are 3, 4 animal species. So we have species richness. I don't want to see, you know, a property that only has live oaks on it. I know we live in Texas and people have an obsession with live oaks, but as soon as I see that, red flags start going off. And I think, you know, as soon as oak wilt hits that property, they're losing everything. So I would like to see species richness. And so whenever I go out and do stewardship plans for landowners, I'll actually document how many, what species I actually see. And then from there, I can recommend, hey, you might want to plant an additional 5 to 10 species, depending on the size of the property, right? Obviously, the smaller the property, probably not as many different species, but the larger properties, I'm definitely going to recommend more. So. All right, so I had to throw in this little GIF that I made. How many of y'all have if any of y'all have ever seen Kim Possible? Her little thing that she says is, so what's the stitch? Well, here I have, so what's the scale? So whenever we look at anything in ecology, we want to know what's the spatial scale? What is the size or extent of an area that we are looking at? Okay. In other words, what's the geographic range? Okay, is it just a neighborhood? Is it the whole DFW area, or is it all of North Central Texas or all of Central Texas, right? It all just depends on like what we are looking at. Okay. And we're looking at the responses of different organisms that are in that area. We look at populations and how they're affected. We look at different species and species richness as well. We're going to look at communities, and then we look at the landscape as a whole. Okay. And so the graphic on the right really kind of shows just what that spatial and temporal scales kind of look like. The gray oval is more of just the landscape scale, and you can see that many of the things that affect forests actually happen, and we see it more in the landscape scale. So in other words, it's complicated. It is very complicated. Sometimes it's really hard to try to explain this to people because there's a lot of things that are going on all at once. And so we have to take in all these different things into consideration. We don't just have native species, we have invasive species. And invasive species are defined as having been introduced from another region or ecosystems, and they cause or are likely to cause harm to our economy, our environment, or our human health. Okay. Now, invasives here, like here in the United States, versus where they're native to, okay, they're not invasive where they're native to, more than likely. Now, we do have native invasives, but more than likely where they're native to, they are not considered invasive. Okay, they have a benefit to that ecosystem. Okay, and so we kind of need to think about that too, because how species or act here in the United States or in Texas is going to be very different. So let's take emerald ash borer, for example. I hope that y'all have heard of emerald ash borer at this point. But it is an invasive beetle that came over here from Asia. And it is killing our ash trees here in the United States. And so that's a really big problem, right? Because our ash trees make up a huge population of our forested stands. Okay. We're talking about millions of trees just in the DFW area. Okay. And if you get further west, go into like Palo Pinto County, where my office is at in Mineral Wells, in some portions of that county, every other tree is an ash tree. And so we're talking about huge portions of our forests that are going to be affected by this. But in Asia, where emerald ash borer is native, it's not a huge forest health concern. In fact, they've done very little research on this beetle because it just doesn't cause an issue there. Emerald ash borer, back where it's native in Asia, only attacks trees that are stressed. Okay, because those trees have evolved with that insect, but our ash trees here in Texas and the United States did not evolve with this beetle, and therefore the beetle is attacking not just the stressed trees but healthy trees in all age classes. I have not seen emerald ash borer not affecting younger trees. Okay, now kind of leading into that, where I talked about how the ash trees in Asia evolved with emerald ash borer, that's coevolution. Okay, and that the definition for that is just when two or more species evolve in response to each other through natural selection. Okay, so over a course of hundreds, thousands of years, they have evolved with each other. Okay, now everything around us, okay, basically is our perception. Okay, our perception of what we are seeing around us can change. Okay, it can change how we see things, right? If I'm looking in the neighborhood, or if you're looking at your neighborhood and all your trees, you have a goal of, I want to keep my trees in my lot, in my neighborhood, healthy, not only for aesthetics, but property value, right? Okay, so our goals in our rural areas versus our urban areas are definitely going to be different. Our perception on all of that is going to be very different. So, you know, whenever I look at the trees in my front yard that are closest to my home, I'm constantly monitoring them for any sign of disease or pests. Now, it's just because I see it every single day and I think I'm going to get on top of it and try to catch it if I see it. But most people are not looking at their trees every single day. But the trees that are up behind my house in my dense forest stand, I'm not paying attention to those as much. If one or two dies back there, by all means, that is less for me to have to deal with later. Okay, because I have hundreds of thousands of trees growing up behind my house that need to be removed at some point. And so my goals and my objectives, depending on where I'm at just at my house, varies. Okay, so we need to take into that into consideration. Okay, and not only that, we need to understand that dead wood and insects play a very important role in nature. Okay, not only are they decaying or helping with the decay process of that wood, but in that decaying process, they're putting nutrients back into our soil. Those insects are providing a food resource for our birds. And then, you know, you can see in this photo right here, you got a bobcat, okay? And that bobcat is also going to be eating on food that is hiding in that brush, okay? And then we have our hawks, our birds of prey, that use the snags, which are dead standing trees, as a perch, right? So we have a lot of benefit from having dead wood and insects in our forested stands. Okay, so getting into the nitty-gritty part. So symbiotic relationships. I hope that y'all have heard of symbiotic relationships at some point. I'm sure y'all probably have heard symbiosis before, but what this is, it's a close, prolonged association between two or more different species. Okay. Now, for my examples, I'm really going to be trying to focus on just two species and trying to define what that relationship is. Okay. So we have three different types of symbiotic relationships. The first one being mutualism, in which both species are going to benefit from that relationship. Commensalism is where one species benefits while the other species is not affected. And then parasitism is where one species benefits while the other species or host is harmed. Okay. So fairly simple, but we're going to be going through this, and if y'all want to speak up and tell me what y'all think it is, great. That was kind of the idea of this presentation, was to try to make it as interactive as possible. There's probably going to be some contradictory or, you may not agree with what I'm saying as far as the relationship goes. I will say on a couple of these, me and my forest health coordinator definitely had some pretty in-depth conversation on, okay, how do we want to define this? Because it could go one or two ways. Okay, or it just gets very complex. Okay, so just understand that a lot of this is, it depends. So we'll start out with an easy one. Our eastern redbud and pollinators. So the redbud has both male and female flowers, so it can be self-pollinating. But oftentimes the pollen is spread by wind, and then it is often pollinated by insects. So our bees, right, are first pollinators that are coming back through after during their migration period. You should start seeing redbuds starting to bloom pretty soon. I think I saw one or two blooming on my way down here to College Station. I know some of our other early bloomers are also starting to get going, but so it's a very important food source for those pollinators as they're moving through. Okay. If you're not familiar with what redbud looks like whenever it doesn't have its pretty purple pink flowers, it also has heart-shaped leaves. So very, very pretty tree. But does anyone want to speak up and think of what type of relationship this is?
Mutualism.
Yeah. Yeah, it's a mutualistic relationship. So both of these species are benefiting. Now, our eastern redbud and the seed beetle. So this little insect lays its eggs inside the pod. So this little insect chews these little holes right here in the little bean pod of the redbud. Okay. And then it lays those eggs inside the pod. Then the adults, once it lays its eggs, and those eggs hatch, the larvae are going to go in there and feed on the seeds. So you can actually see on the little seeds, they have chewed through little pods. Okay. You may also see this with on acorns every once in a while, but those are acorn weevils. Those are not fun to deal with, especially after you've been collecting all that lovely seed. So yeah. But anyone have any ideas of what this relationship would be?
Parasitic.
Yeah. Parasitism. So definitely the beetle is benefiting from this. Redbud, not so much. Now, we could call this commensalism also, okay, because is it really causing harm to the redbud overall, like that mother plant? No. Is it causing harm to that plant's reproductive abilities? Yes. So it all depends on what goal and objective we're trying to look at. All right, everyone's favorite topic, oak wilt and oak trees. So Breptozilla fagocerum is a fungus that invades those water conducting vessels in the oak trees. Those water conducting vessels are called xylem. And so oak wilt affects all oak trees. However, some of those oak trees are going to be affected more than others. For example, red oaks, if they get oak wilt, they die within about 3 to 6 weeks. Live oaks, if they get it and are left untreated, can die within 3 to 6 months. Okay, so nice, lovely little disease that we get to deal with here in Texas. So, any ideas on what this one would be? Go ahead. It is parasitism, but we'll kind of go in a little bit more detail on the oak wilt disease cycle. And so when we talk about the spread of oak wilt, a lot of times we're talking about red oaks and live oaks. Okay, so with red oaks, we have these little knitted beetles, okay, that will go and feed on the fungal mat on an infected red oak. Now, it's important to note that other oak trees, so like live oaks and white oaks, do not produce fungal mats. These only occur on red oaks. Okay, so the knitted beetles will come and feed on this nice little fungal mat. It smells like rotting fruit, so very, very fruity smelling, very sweet. And then those little knitted beetles will take those fungal spores and then they will move to a fresh wound on either a red oak tree or a live oak. Okay, so there's our relationship there. Now, to get a little bit more in depth, live oaks can then infect other live oaks or even other red oaks by interconnected roots. Okay, because they can graft their roots together. And so that's how we get the below ground spread. Okay. So when we talk about oak wilt fungus and the knitted beetle, so again, like I said, the fungus, the fungal spores or fungal mat has a very sweet, fruity odor. So if you're ever walking through a forested area that's heavily covered in red oaks and you smell that sweet, fruity odor, you're more than likely walking by a fungal mat. But that knitted beetle is very much attracted to it. It goes and lands on that fungal mat and feeds on it. It then picks up those fungal spores, kind of like how a bee would with pollen, and then it moves to a fresh wound on another oak tree. And so just to kind of give y'all an idea of just how tiny these little tiny beetles are. So this is a dime right here. These two little dots are the two little knitted beetles. They are super, super tiny. But kind of a interesting little thing. People oftentimes ask me like, hey, do we see those easily, or can we trap them or get rid of them? I don't see that happening. There's also, the knitted beetles are a huge genus, meaning that there's a bunch of different species of these out there, and they kind of have their own ecological role, right? And they don't know that they're going and picking up those fungal spores. They're just going to get food, right? And so with that, this relationship right here would be considered mutualistic. Okay, because both of these are benefiting, right? The oak wilt fungus is getting picked up and moved so it can continue its reproductive cycle. And then the knitted beetle is getting a food source, right? All right, so hackberry and nipple galls. So these are caused by the hackberry phyllids, which are a genus of very tiny little plant hopper-like bugs. You can see one of them right here, the adult, on this little cage mesh right here. And so the hackberry tree responds to their presence by forming this warty gall. And you can see that in this right photo right here. And so those nymphs, while they're in there developing, they feed on those juices or other parts of the tree, and then the tree responds by forming a distinctive gall around that feeding insect. Okay, and then in late summer or early fall, those insects are going to emerge as winged adults. Okay, And so this is one where it could go one of two ways, right? It just kind of depends on how we look at it. Does anyone have any guesses as far as what this relationship might be?
Is it neutral?
Yeah,
Capitalism, where it's kind of neutral, neither one benefits nor is harmed.
Okay, well, they benefit.
commensalism.
Yeah. So could definitely go with commensalism, but my mind immediately went to parasitism because the little tiny little insects are injecting or taking, something from the tree, right? So if you have a lot of these, it could definitely cause harm because it does, whenever those little warty growths pop up, it does affect the tree's ability to photosynthesize. So if the tree is already stressed from something else, it could cause more harm, right? But if the tree otherwise is healthy, it could be commensalism, right? Because it's not really causing that much harm. It's not hurting the tree overall. So it kind of just depends on how we want to look at it and what is going on overall with the tree. All right, so hackberry and the hackberry emperor. So hackberry trees are a larval host for the hackberry emperor. You can see the adult butterfly right there on the bottom right. It's the only host plant for this species of butterfly. And so the larvae of this butterfly feeds on those leaves and the buds of the hackberry tree. And then there's rarely enough caterpillars to actually cause severe defoliation on these trees. So we're not really that worried about it. The adults will then feed on the hackberry sap, any decaying fruit, and animal droppings. So anything that kind of has a very sweet odor also. So a lot of people, I get a lot of landowners who absolutely hate hackberry, and I get to talk them down for removing every single one of them. And I get it, they're annoying. They pop up in the worst places, oftentimes along fence lines. But if we were to remove every single hackberry out there, we would lose this butterfly, right? And so this relationship is going to be commensalism. And so both of these are going to benefit from this relationship. Or one's going to benefit without harming the other. All right. So ash trees and emerald ash borer. So I've already kind of touched on this a little bit earlier, but emerald ash borer, also known as EAB, is an invasive wood boring pest that affects ash trees. It is native to Eastern Asia, but it's been in North America since 2002. It's been in Texas since 2016. I thought I fixed that. The adult beetles are going to feed on those ash leaves, and then the female lays eggs on the bark. So where, if you ever look at a tree's bark and it has these little grooves in there, it lays its eggs in those little grooves. And then they hatch, and then they feed on those inner layers just below the bark. Okay. Again, it's going to affect all ages of ash trees. It does not have to be stressed before the EAB moves in. Okay, it's not like how it is in Asia. So I kind of think this beetle is kind of cute. If it didn't cause so many issues, I would probably welcome it more. I think it looks adorable with its big old eyeballs. It looks like a dog to me, but that's just me. So I'm a weirdo. So this relationship, I'm sure all of y'all can guess, is going to be parasitism. So just in case y'all aren't aware, whenever the larvae are in there feeding, they are making these S-shaped galleries here. It does get a little bit more confusing as, more and more EABs start affecting this tree. We're going to get S-shaped patterns going in all different directions. So you're not going to see the pattern as easily, but this one is nice and just kind of singled out. So this kind of gives you just a general overview of the life cycle of emerald ash borer. So like I said, the female lays her eggs on the outer bark, typically 40 to 70 eggs. The larvae will then hatch, and then it feeds inside that tree right underneath the bark. It then will emerge and it starts feeding and mating. So here in Texas, because of our weather patterns, we typically only have one generation per year. In some parts of the United States, I believe further up north, sometimes they can get two generations just because it's colder. So now, bark beetles and pine trees. So beetles co-evolved with conifers. Okay, so if you're not familiar with what a conifer is, basically, it's an evergreen pine tree, is a type of conifer. So beetles are going to detect those chemicals that are released by those stressed trees in those pine forests. And then the bark beetles then feed or target those trees and then feed on the phloem of those conifers and make galleries. And so they kind of help with the whole breakdown process of those already stressed out trees. Okay. At one point, this was actually kind of helped us with our forest health. Okay, so it would get rid of those weaker trees for us. The only problem is now we are constantly in stress. Those trees are constantly being pushed to the max because of climate change, because of our drastic weather patterns and the shifts that keep occurring. Okay. But when those trees are stressed and those bark beetles are in there, it ends up producing like these sexual hormones that end up attracting more beetles. So it encourages even more of them to attack those trees. Okay. And so this relationship is going to be parasitism. Okay. So it could, if you're looking at just, is it a good thing for overall forest health if we weren't dealing with all the other stressful environments or things that are happening in our environment? I would say yes. But in today's world with our extreme temperatures, I would definitely go more with parasitism, just because it's taking all of our trees because they're all being stressed because of everything that's occurring. All right, so aphids. I did not know, I have to say this is very random, but in Bug's Life, if you have ever really paid attention in that movie, the little green little baby insect that's being carried around is an aphid. And I had no idea until recently. And so now I'm just focused on aphids being in Bug's Life and having that image stuck in my head. But if you aren't aware, aphids suck the sap from the tree leaves and those stems. This causes these areas to become discolored. It can cause leaf curling and yellowing. It can also stunt the overall growth of that plant. Okay. Typically, it's not a problem for our larger, more mature trees, but whenever your trees are smaller and younger, they are going to be affected more. Okay. So like a nice mature pecan tree that's in someone's yard, a lot of people will call me and say that they're annoyed with what they call a honeydew is landing everywhere. It's making everything very sticky. And people will call me trying to figure out, well, what do they need to do to get rid of the aphids? And I just kind of tell them it's not a problem because your tree is very big and it's not going to stress them out that much for them to be there. But that honeydew ends up attracting ants and flies and hornets and yellow jackets. So it's also a very sweet kind of food source for a lot of insects. Okay. If honeydew is not washed off of plants, it can cause what we call sooty mold, which ends up blocking the sunlight for those leaves and ends up disrupting the whole process of photosynthesis. Okay. And so this relationship here is actually going to be parasitism, right? So even though it's not going to typically be an issue for our more mature trees, it can still be considered parasitism. Okay, so ladybugs and lacewings. So we have our ladybugs over here with these three photos, and then we have our lacewings on this side right here. Both of these are natural predators to aphids and other tree pests, including scale, which you can actually see here in this top left photo with this ladybug. Okay, So these insects actually feed on these pests, and there's a lot of natural predators of aphids, of scales. And so a lot of times they're not too big of an issue because they can be maintained by a lot of our native insects, right? Our ladybugs and our lacewings. Now, I will be completely honest, until about a couple of years ago, I had no idea that these little black spiny insects that have these orange dots on them were ladybug nymphs, little baby ladybugs. They look like creepy aliens, and you would not picture that with a cute little ladybug. But who knew? But at both stages of the life of a ladybug, it is predatory. Unlike lacewings, which are only predatory during their larval nymph stage. Okay, so you can actually see in these pictures I have the nice little pinchers, and they're eating little aphids. And so this relationship between ladybugs and lacewings and then trees is going to be mutualism. Okay. So twig girdlers. These are a species of longhorn beetles, and you can kind of see that nice long horn here, their little antennas, that end up girdling small branches of trees. These cause them to end up falling to the ground. All right, so what happens is that they will end up chewing around this twig, and then it ends up staying intact. The wind will come through, kind of disrupt it, and it ends up breaking off. Okay, but this would be a female longhorn beetle that ends up chewing around this. Of course, she's going to leave that inner portion, but she's looking for a twig that's around 3/8 inch in diameter. And then after she ends up girdling it, she lays her eggs under the bark towards the dying tip of that branch. And then when that branch falls to the ground, the insect ends up overwintering on that branch. Okay. This rarely causes serious harm to a tree. It's more of a nuisance. I can guarantee you this is definitely more of a problem for, your landscape trees. And it's mainly just because you're going to notice it. I get landowner calls who are freaking out that their yard is now covered by a ton of twigs. And they think that their tree is dying, and it's not that big of a deal, honestly. If this does bother you and you don't want that cycle to continue, all you have to do is go rake up those little twigs and get rid of them, either burning them or throwing them in the trash. But this relationship, depending on how you want to look at it, I consider it commensalism. Okay, just because I don't think that it's overall that big of a deal. It is definitely more of a nuisance. And again, if you have a large property and you have a ton of trees that are nowhere near your house, where you're not looking at them every single day, you wouldn't know the difference. Okay. But because most people, especially in urban areas, are keeping up with their yards, and they notice when hundreds or however many twigs are all over their yard, they start noticing that and they think, oh, I have an issue, because their goal and objective is to keep that tree looking as great as possible, right? That is their pride and joy, especially if that's your one tree, or you only have a couple trees on your lot, right? But in rural areas, not a problem. So the translucent oak gall, I actually really like this little gall. I found one of these. It's actually, this is my picture here on the left, on a blackjack oak in Palo Pinto County. And so it looks and feels like a pink grape. It's such a weird little feeling. I tried to preserve it, and so I froze it, and I was going to put it in resin later, and then it just turned to mush. So I don't recommend doing that. I got to figure out another way to preserve a future one. But what happens is that this little female wasp will end up laying her eggs on the veins of that oak tree or oak leaves. And And then the tree responds by forming this translucent ball around that larvae. Okay, that ball then serves as a food and shelter source for that larvae as it develops. Okay, now this is what the adult wasp would look like. Now it's a non-stinging wasp. We don't see any stinger here. And it's very, very tiny little exit hole. Okay, so this would have been its exit hole right here. So you can see it's pretty much the size of this little laser pointer. Okay, very, very tiny. And so not a big deal at all. Now, whenever I see this, obviously a lot of galls are going to be more of an aesthetic issue. But depending on how you want to look at this, you can see it as either parasitism, which is how I labeled it, or you could also label it as commensalism. Okay, because overall, is it really affecting the overall health of the tree? Probably not. But I wanted to go ahead and label it as parasitism because this female is basically when she lays her egg right into it, she's basically putting a parasite into the tree itself, into that vein, and then the tree is providing a shelter for it, right, as it develops. And so as you know, it kind of just depends on how you want to look at it. So all right, so ambrosia beetle in trees. So ambrosia beetles are starting to be more of an issue here in Texas, especially here in North Texas. It's a very diverse group of beetles that typically are going to attack our dead or dying trees. However, we do have invasive ambrosia beetles that attack healthy trees. Okay. That seems to be a trend with our invasive insects or invasive species. They're going to disrupt our natural order. Okay, so adult beetles create galleries, and then they introduce a fungi into those tunnels. Okay, so here in this picture on the left, you can see these nice little tunnels, and that's this arrow actually points to an adult beetle here in this gallery. But this tunnel over here has this white substance in it, and that is actually a fungi. Okay, so the adults farm this fungus for food. Okay, that's kind of an interesting concept of an insect farming a fungi, but this is pretty common. I don't want to say pretty common, but I can think of one other instance where insects are farming a fungus. One of those being the leafcutter ants. They farm fungi, but they actually also keep a beetle as a slave as well. That's really interesting to see. They go and capture a beetle, take it back to their hole, and then use it as a slave so that the beetle is now farming that fungus for them. It's really kind of weird. But when this fungus is being farmed and as it grows, it ends up blocking those xylem vessels inside the tree, which ends up blocking the movement of water and nutrients through the tree. Okay. And so here in this middle photo and on the right photo, you can see what we call little noodles sticking out of the tree. All this is a sawdust that the beetles are pushing out from those little galleries. So this relationship is going to be parasitism. So now the ambrosia beetle and the fungi that they farm, these ambrosia beetles have these little structures called the mitochondria. And so you kind of think of them like little backpacks, right? And so these structures act as pockets or a backpack that allow them to transport those fungal spores over to a new tree. Okay. And so once they attack a new tree, they end up farming that fungus. And then that fungus is used as a food source for their larvae. Okay. As those larvae are developing. And then before they end up emerging from a tree, the beetles are going to then pick up that fungus back up into their little pouch, and they move on to the next tree. All right. And so this species has co-evolved together over time. It has co-evolved with this fungus over time, right? Because it's its food source. It helps provide food for its larvae, and they want it there. Okay. So this relationship here would be mutualism. Okay, so when we look at relationships out in our natural world, I would like to think that we need to consider not just think about the relationships, between the insect and the tree, but what else is occurring, right? Because there's a lot of stuff occurring that we may not see. And I'm a nerd, and I find this extremely interesting that they have a little backpack that they carry or that they have on them as part of their structure. So it's kind of a neat little fact. But I believe that's all of it. So we are on social media. On Facebook, we have 2 different pages, the Texas A&M Forest Service's main page, and then we also have our wildfire education and prevention page as well. We are also on Instagram also, and then my contact information is at the bottom. And then I also have a link tree, which if you scan that QR code, it will take you to a main page that has links to all of the topics that are listed right there. So does anyone have any questions for me?
Yeah, Kimberlee, there are several in the chat.
Cool.
It looks like they went along with what in your different slides. Right now they're all from Grace Darling. She's been really paying attention. Early on, do aquatic species within a forest stream count or have any effect when evaluating the health of a forest?
I would assume so. It also kind of depends on like what type of forest are we looking at. So if we look at like a mangrove tree forest, right? A lot of aquatic species actually use mangroves as a nursery while their young are developing. And so I think it really it depends, honestly. I don't know any off the top of my head here in Texas, but I will be completely honest with you. I try to stay away from anything aquatic during my studies because it's so broad and very specialized. So I specifically stayed away from those ponds and fisheries courses for a reason.
Okay, next question is, if you don't have a red oak in your forest or backyard, are your live oaks safe from the
No.
live oak wilt?
No. So, okay, even if you don't have red oaks in your backyard or in your neighborhood or even in your area, your live oaks are not safe. Okay. And the reason for that, and there's a couple different ones, but the beetle itself can fly for miles with those fungal spores on their body. Okay. But also people love to move firewood. And so if they moved a red oak wood that had died with oak wilt and now has potentially formed a fungal mat, they have introduced those fungal spores to that area where those knit-a-doodle beetles can now go feed on that fungal mat and infect your live oaks. Okay. So what I recommend doing is making sure that anytime that you prune on your oak trees, doesn't matter the species, making sure that you spray those wounds, ideally immediately, but no later than 3 days after making that pruning cut. You can use either regular spray paint, which costs $2 to $3, or you can, be fancy and get pruning spray, which costs 10 to 12, depending on where you buy it. I will tell you that the pruning spray kind of goes on like black tar. Don't wear any nice clothing whenever you spray that pruning spray. It will ruin your clothing. But spray paint, most people have it. It's pretty easy to get a hold of. But that creates basically a barrier between the knit-a-doodle beetles that are carrying those fungal spores and then that fresh wound on your oak tree. It also basically creates a seal over that sweet smell of the sap that those oak trees are producing from a fresh wound. Okay. We also recommend to not prune your oak trees from February through June. But I go a step further and not recommend that people prune their oak trees until the fall. So once the trees start losing their leaves for the year, it's good to go. For oak wilt, I highly, highly recommend you go onto our texasoakwilt.org website to learn more information about it. We have a lot of good videos on there and other documents that you may find helpful. But basically just educating yourself on oak wilt is extremely helpful because a lot of arborists or tree companies love to immediately jump to oak wilt. So knowing what you're looking at, I think, is extremely important as a landowner, as a homeowner, to make sure that you are basically have the right information at your fingertips. So.
Okay, can you prune infected hackberry branches to stop the spread of the beetle?
No, so I'm assuming that that's going to those little the little nipple galls. No, I wouldn't, honestly. Because one, they're not really causing that big of a harm, but it's not going to stop the spread of those insects. Just because they do have wings. They're little leaf hoppers. So I just wouldn't worry about it.
Okay, what do the male twig girdlers eat?
That's a really good question that I have not ever asked. To be completely honest, it's something I probably should ask that, and I have not.
Okay, that's something for all of us to look up. Oak gall wasp, what is it? Okay. Can oak gall wasp use any oak species?
Yeah, so it depends on the species of the oak gall wasp. So there's a lot of different ones. That particular species of gall that I had shown of the translucent oak gall, that one I think only shows up on a few species, and the only one that I've seen it pop up on here in Texas is blackjack oak. But a lot of the other gall species you'll see will pop up on a variety of different oak species, or I'll only see them on certain ones. It just depends because there's so many different species of galls forming insects. A lot of the ones that do interact with oaks are going to be wasps, but it really just depends. So.
Okay, are there any strides being made in combating the EAB?
So EAB, it's a fairly new thing. So it's only been in the US since 2002, so only 22 years. And science can be a little slow at times, and this is one of them because it had never been researched before where it's native. Now we do know that treating your trees with a systemic insecticide does help protect them, but you do have to continue those treatments every 2 to 3 years after the initial treatment. And so we are still researching them. We do put up traps every year to try to track where they're at and to see where they have spread to. We're actually going to be deploying our traps in 2 weeks. So if you see any purple sticky traps hanging around, that's what those are. And we did see some pretty heavy spread of emerald ash borer last year. It actually started going down more towards Waco, where we found it at a campsite. So we believe that it was brought in from infected wood. So we really want to make sure that people aren't moving infected wood. There are some other states that are having some success with introducing predatory wasps that actually they have a parasitic relationship with the emerald ash borer larvae. But we have not had any success here in the state just because it's too hot here and that wasp can't survive. So there's some theories out there that say that we're gonna get to a certain southern threshold where emerald ash borer won't be able to survive because it just gets too hot. But we just don't know where that threshold is, so.
Is climate change impacting the 3 types of relationships you described?
Yeah, climate change is impacting, I think climate change is really impacting a lot of the relationships that I talked about. We are seeing, because of the extreme weather patterns, we are seeing more wood boring insects out there. And so that's the one that immediately comes to mind, because after the last drought that we had that lasted 2.5 years, and even the winter storm of 21, those insect borers, pretty much any tree that you look at probably has wood borers affecting them right now, because of how much stress those trees have been under the last few years. And so I definitely think that climate change is impacting them. I don't necessarily have an answer for every single one of those relationships that I described. But I'm sure as more time continues, we're going to be able to figure out more on how it's really impacting our environment. The problem with that is that a lot of these relationships and these observations take time to really put together your thoughts. And so again, it's a slow process at times.
Okay, can EAB survive forest fires?
Yeah, that's a really good question. I don't think we have an answer for that, like a definitive answer for that, just because emerald ash borer has really been, as far as in the state of Texas, has really mainly just been in my region. I actually have 12 counties that have emerald ash borer. And none of the areas where I've had obvious signs of emerald ash borer, none of them have had wildfires or anything. And so I haven't seen anything. That would honestly be a really interesting study to look at potentially, to see, how they respond to forest fires. I would think that though, the larvae could potentially survive. Just because they're inside that trunk and they're underneath that nice protective bark layer. As far as the adults, they can fly at least a mile. And then they hang out mainly in the tree's canopy. So I would think that they would, as long as the flames stay low, they could potentially survive. Potentially. But
Hey, right now, I don't see any other questions, but Grace posted a link in the chat for an article from the Proceedings of the National Academy of Sciences called Fungus Farming Insects, Multiple Origins and Diverse Evolutionary Histories. So
awesome.
if anybody is interested, find it in the chat, a link to it in the chat. Does anybody else have any questions? Just go ahead and unmute and ask it.
I think this was fascinating. I really enjoyed it, Kimberlee, and thank you for hanging in with us while we, you didn't know where to log in, but anyway, thank you. I hope to hear from you within the 12 months to say we solved the EAB problem.
The EAB problem's not going anywhere, unfortunately.
I think I read somewhere about genetic modification and what is it, genetic engineering using male borers from Japan. And if we,
Problem is, some states you can do that in because it depends on what our regulations are, but also like with the parasite wasp, parasitic wasp that has been released. It's done really well up north. They've actually gotten 4 species of the parasitic wasp to survive up north. But the furthest south I think they've been able to get a population to take hold is Tennessee. Everywhere else, they're still working on it for 8 years later, trying to get a population to take hold. Just because it gets too hot for them. So, and I think we've tried it a couple times and it hasn't worked. So we'll see.
Well, I hope your funding is not in trouble, so you can continue that research.
Yeah, that's the hope. So far, we've been told to keep moving forward as if, nothing's amiss. So our funding so far has not been affected.
Well, thank you so much for taking the time to speak with us today. That was great.